Hi guys, hope all of us are doing great. Uh, Today we are going to look at one of the addition reactions, and that is hydration reaction. And in us trying to figure out how this particular process is taking place, we are going to use one of the previous examples that we had used in our first case for the electrophilic halogenation uh, reactions that we had considered in our first video. And that was the reaction with the multiple bond. So in this case, we're going to borrow from that specific discussion. Now we had said that if we have a multiple bond, which is either double bond or a triple bond, uh, which is having a reaction with a halide, we had mentioned and said that this is going to have an effect of breaking of this double bond, which is basically a sigma bond, and this is going to lead to the formation of two specific. This is going to lead the breakage of a pi bond, and this is going to lead to the formation of two new sigma bonds, which are going to be formed by these two specific carbons in this particular molecule. And from this particular discussion, then we are given one of the general examples, whereby we said that we can be able to illustrate the reaction mechanism of a compound which is of this nature. Now that is still a double bond. Now if we try to have this particular molecule react with another molecule of XY, then therefore we're going to see that from this particular molecule, if it's some type of or some kind of a compound like a protic acid, then therefore we're going to have this particular compound having this electrophile being formed, and then this double bond is going to be on this electrophile, and therefore this is going to lead to the formation of a carbocation, which is going to be illustrated as such. So therefore from this particular case, then therefore we're going to have this electronegative part of that specific compound, which is going to pick on that or attack on that carbocation, and therefore lead to the formation of what we are going to refer to as a final product. So therefore we shall have this compound illustrated as this, whereby we have this one as a final product. So in that particular case, this is going to be the first step of this reaction, and then this is going to be step 2. Now this step 2 is analogous to the nucleophilic substitution and nucleophilic substitution reactions that we're going to see in some of the reactions, which is basically referred to as N1 reaction. Now in this particular case, we are given a specific example, which we said that this particular example is analogous to hydration reactions, which are going to be taking place, which is basically the addition of water molecule, or rather the addition of water to specific compounds like alkene. Now I'm going to give a specific example for this particular case, and this is an example that we're going to follow from the basic mechanism that I've illustrated basically on the board. So we're going to have this double bond, which is going to undergo hydration. So in hydration process, we're going to see that the OH group together with the H positive group is going to be added to this particular alkene. So therefore, this kind of a reaction takes place in the presence of a strong acidic aqueous solution, which basically is going to be illustrated using this H positive ion, which is basically a proton. So therefore, we're going to have the final product illustrated as this one, whereby we are having addition of OH group and hydrogen at those specific points. So we can have a specific example, maybe, or illustration of a mechanism of this particular example for alkenes, whereby we're going to see how that subsequent steps take place. So for instance, if we had a molecule of this specific kind, and then we're performing this hydration process, then therefore we're going to have the final product as an alcohol, which is going to be illustrated as such. So therefore this is a secondary degree, this is a secondary alcohol, and therefore we are going to have a reaction mechanism that is similar with the one that we have illustrated. So as we had shown in the first case, there was a formation of what we refer to as an electrophile. And therefore, in this particular case, having said that this is performed under a strong acidic aqueous solution, therefore this double bond is going to be on a proton which is positively charged, and this will lead to the formation of an intermediate product which is a secondary cation, which we can be able to illustrate as such. So therefore we are going to have this one as a hydrogen which has been picked from this particular point, and that a positive charge at that particular point. And then a subsequent reaction is going to involve a water molecule now, which is having these two lone pairs of electron on a hydrogen atom, and therefore it's going to have that specific reaction on that particular point. This illustration is going to be elaborate. So therefore, that one is going to lead to the formation of this particular intermediate, which is going to have a positive charge at that particular point. And then we are going to see that in this particular case, which is the last one, we're going to have this particular. Now we had said that this specific reaction takes place in what we call can take place in what we call a protic acid. A protic acid is an acid which is basically ready to give out what we call the H positive, which is a proton, and therefore we can consider a general case for the acid which is H combined with a halide. So therefore this particular case, we are going to have this one as positive and that one. So therefore in this last reaction, we're going to have a negative, which is an anion picking on this particular proton, and then this is going to move to that particular part, and therefore from this particular reaction, then therefore it's going to lead to the formation of that specific alcohol. Now suppose we have an example whereby we're going to consider the position at which this particular H group and OH group are going to be attached. Then we're going to try and figure out what product takes priority in that case. And in this particular scenario, then we're going to consider what we refer to as Markov-Nikov's rule. And I'm going to give one of the examples to illustrate that particular case. So in case we have a molecule like this, which is a double bond, and this molecule is undergoing hydration. It is a water in the presence of a strong acidic solution. This therefore is going to lead to the formation of two products, and we can have this one illustrated as OH, and this one is a H group at that specific point, and then we have a methyl group at that specific point. So this H group is going to be attached here under OH group due to the breakage of that particular the breakage of this particular bond at this specific point. And therefore this one we can also consider a case whereby we are going to have this product formed as a OH group at this specific point, a H group given as such. So therefore if we try to look at those specific products, then therefore we are going to have to consider which one has a priority of formation, or the degree of formation of this specific product. If we try to look at this, we are going to have this one named as, this is the first one is 3-methyl butane 2-ol, and then the first one is this is 2-methyl butane 2-ol. So the formation of these specific two products are not going to occur in a similar degree. So therefore it's pertinent for us to try and consider which one is going to be a major product and the minor product. Now that is where the aspect of Markov-Nikov's rule applies. Markov-Nikov rule applies. Now in this particular rule, then therefore it's going to consider at which point this OH group attaches, and it's also going to consider the stability of the products which are going to be formed. And therefore this rule states that whenever the addition of a protic hydrogen, like the one that we have shown above, is going to occur to double bonds like this alkene, the proton becomes attached to the carbon with the fewer alkyl substituents. So in this case, Markovnikov's rule is trying to consider the case whereby this reaction is taking place, and therefore trying to give a priority where the OH group is going to be attached. And therefore it states that this OH group, this acidic group, the proton is going to be attached to the carbon with fewer alkyl constituents. Therefore, it will consider the case for the second product, which is going to form the major product according to Markovnikov's rule. So therefore, the alternative product then therefore is going to be the minor, and we're going to see a condition also which from the Markovnikov's perspective leads to that. So therefore, for this case and for the halide group or the alternative OH group that we have given in this particular case, is going to be attached to the carbon with more alkyl substituents. If we try to see this specific point, then therefore we can be able to consider and say that from the second argument from Markovnikov's rule, then therefore we are going to have the OH group attached to the carbon with more alkyl substituents, as compared to this one has got one alkyl substituent, this one has got two alkyl substituents. So for the X, which is we had considered for the alkyl or other groups like the OH groups which are more electronegative, they're going to be attached to this particular carbon with more substituents. Now that is in accordance to Markovnikov's rule, and therefore it's going to give a priority for products such as this one, which are going to undergo hydration, and try to dictate which are going to be the major products and the minor products respectively. So then therefore then in any reactions that we're going to do that is concerning hydration, or maybe which requires some of the conditions, then therefore we're going to infer from some of the rules which basically like the Markovnikov's rule, which are going to give us the priority of which product is going to take precedence of another one. Now I hope that this concept of hydration reactions and the reaction basically has assisted to try and create a relationship between this one and the reaction of electrophilic halogenation. And this basically sequence of reactions that we're trying to consider in organic reactions are of very much importance to us, since that I had mentioned in our first video of the applications of these individual reactions. Now in our next discussion, we're going to consider other kinds of reactions which basically are in correlation with this. We are going to see and appreciate their various applications in our day-to-day life. So for now, we are going to stop this on this specific point. Kindly check on our description box so that in conjunction with other videos, this is going to make more sense as we try to figure out how these specific organic reactions take place. So that is it for now, guys. Bye. God bless you.